702.
The Naked Scientist.
Straight to the lines. We're going to start with Ross in Thornton. Good morning, Ross. I hope you're well this Friday.
Yes, thanks very much indeed. And in fact, I'm a first-year student at the age of 76, and I'm doing psychology.
Wow.
And the reason for my doing this study is to eventually answer the question, and I hope Chris Smith can help me with this. And my question is, which brains are the best, male or female brains?
Wow.
Good luck with that one. The answer is that it takes two to tango, and nature has spent millions of years evolving us to the way we are and evolving us into a way that makes us as successful as we possibly can be to meet the needs, requirements and pressures applied upon us by our environment. And the same is true of every living thing, where there are two sexes, and there are two sexes. Plants come in male and female forms. Animals come in male and female forms. Some animals can switch sex accordingly. The whole purpose of males and females is actually as a machine to generate genetic diversity, because that is how you optimize yourself to be the best fit you can be with your environment. But certainly there are specific character traits that segregate with male and female brains in both humans and other animals. And this is probably under the influence of development. So your brains may develop slightly differently because of the genetic cargo you inherit from your parents, and those genes translate into various signals that make the brain develop in a certain way. As we go through life, of course, you're subject to environmental, social and educative pressures that also may force your brain to develop or be moulded in a certain way depending upon your upbringing. That it certainly has an impact. And then there is the impact of hormones, and males have more testosterone than females. Females have more estrogen than males, and as a result of that, that also has an influence on the way in which our brains tend to function and are moulded across our life course. If you look at who performs best at certain tasks, you do find there are some, on average, differences between men and women. There are things that women outperform men on. There are things that men outperform women on average. And the reason I'm saying on average is it's a bell-shaped curve. In other words, if you drew a line at the shape of a bell, then you're going to see an average, which is at the top of that bell. And in men, for some tasks, they'll be to the right of or better than women, whereas for some tasks, women will be better than men. But there's a strong overlap in many cases, so there will be many women who are better than many men and vice versa. So it's not as simple as saying who's better, who's best. The answer is that everybody is needed, and everybody's skill set is needed to complement the skills and strengths of each other, because that's what makes humans and other social species like us that work together collaboratively so successful.
Is that neurophysiology? Is that hormonal, or is that, Chris, based on our society and sort of gender norms that have been entrenched over millennia? For example, men were seen or are seen hunter-gatherers, so they have to be practical, and in terms of go out and go hunt a mammoth, for example. I'm going way back now. And women socialize to be gatherers. Is this neurophysiological, or is this simply just environmental?
It's all of the above. And if we take humans out of the equation, let's look at, say, gorillas for an example. The males and the females exhibit enormous sexual dimorphism. The males and the females look totally different to each other in terms of body stature and size. In other words, there are, driven by the genetic cargo you inherit, the influence of hormones, and then your opportunity to train up your body to reach your developmental potential, you end up with a very different body shape, size, structure, and strength in one sex compared to another. And that's because how do you succeed in that species? Well, you have to ward off other rivals. How do you do that? You have a massive, great body. So there are differences. There are differences between males and females in many different species, and that's all arrived at by evolution endowing us with the best prospects in order to be as successful in the structures socially and environmentally in which we live.
Get your calls in for Dr. Chris Smith, the Naked Scientist. Here's a message that's come through. Dr. Chris, I find that when I suffer from a blocked nose while I'm sleeping, turning onto my side almost immediately, that unblocks my nose. Am I mistaken, or is there an explanation for this situation? That's from George McDonald in Stellenbosch.
Hi, George. The answer is it could be that what you're calling a blocked nose is a congested sinus. If you look at the X-ray of a person's skull from the front, you see where the bones are. There are some darker patches under your cheeks and above on your forehead, above your nose, and deeper into the head there are also some spaces. These are a range of different sinuses which are cavities in the bone. You don't want to have a skull which is solid bone because it would be enormously heavy and you'd need even more muscles and stronger bones elsewhere in your body to support such a big, very heavy head. So you make it lighter but structurally strong by having cavities. But if you have cavities, you've potential spaces, you've got to line them with something, and those are the so-called air sinuses. They're connected to your nose and they are lined with the same mucus-producing machinery that the rest of your nasal passages are. And so an infection in one place or inflammation or an allergy in one place can spread to those other places. So what we call congestion is very often sinuses, these blobs of space inside our skulls, which are filled with mucus and inflamed. And they drain into the nasal cavity through a series of connecting ducts. And because the fluid level in them, or the mucus, will settle under gravity, if you move your head around, then you move the level of that fluid. And if you put yourself in the right position, you will help the fluid to drain out down the duct which connects that sinus to your nasal cavity. So that may well be part of what is going on. A lot of what we call congestion, though, when you have a stuffed up nose, isn't loads of snot and mucus up your nose. It's actually inflammation in the tissue. So the linings of the nose become swollen and bigger than they would normally be. That takes up more space and it makes your nose feel blocked up. It's not blocked, it's actually congested with its own tissue, which has narrowed all the airways. So that's part and parcel of it. And you may, by shifting around your posture, change the way in which that tissue congestion is happening as well, which might make things a bit better.
Seems like blocked noses are a thing in Cape Town at the moment, because here's a follow-up from Tanya. She asks, why do I get a dry mouth at night, even when I don't have a blocked nose? Every night, not every night, but often. Thanks, Tanya.
Tanya, the most common reason why people will complain of a sore throat when they wake or a dry throat is because they may not realise it, but they're actually sleeping with their mouth open. And some people do this more than others, and things that block your nose up, such as allergy, such as having a cold, or other things such as if you are a bit big and you end up with blocking of the because of flabby tissue around the neck, for example, you can actually sleep and snore more. And if you do all those, if you can sleep with your mouth open and snore more, both of those things will actually encourage air to travel not through your nose and then down into your lungs, which means it gets pre-warmed and pre-dampened going through your nose. It goes straight to the back of your throat and dries it out, and that can make it sore.
A lot of focus this morning on the upper respiratory system. Brian's asking, hi guys, why do we only breathe in and out of one nostril at a time and not both? I don't know if that works. I think I breathe through both nostrils.
You do, but I know exactly what Brian means, and he's spot on. People will often say, it's weird, one of my nostrils seems to work better at some times of the day and the other one works better at other times of the day. And in fact, that is precisely what happens, because rather than having both nostrils equally open at the same time, if you talk to an ear, nose and throat specialist, they will tell you that the nose cycles between one nostril being dominant and the other being not recessive, but non-dominant. What they mean is that one nostril is more open than the other at different times of the day, and the nose switches alternately between them with a cycle time of minutes to hours. Why does it do that? Because it does do that in all of us, giving the impression that one side of your nose is blocked up and the other works better. The reason is to do with how the smell system works. When you are smelling smells, you're breathing air up your nose, and at the top of your nose is a layer of tissue called the olfactory epithelium. This is effectively chemically sensitive tissue where cells there have receptors that can detect smell molecules. Some smell molecules are big and bulky, and they take a really long time to get out of the air and latch onto those receptors, activate them and tell your brain, I'm here, you can smell me. Other molecules are really small, really agile, and they do that process really fast. So the way in which you optimize your smell system is you have one area of the nose where you throw the air past the olfactory epithelium as fast as you can, because you deliver as many smell molecules as fast as possible, which makes that ability as sensitive as possible. But to pick up the bulkier, slower, harder to detect molecules, you need slower airflow. So the nose has the other nostril, which it slows down the air by narrowing a bit, and in other words, the bulk volume of air is moving more slowly. And as a result of that, you make it more favourable to detect those other smell molecules. But you don't want to use the same nostrils all the time, because the system would become fatigued by always trying to smell one flavour, as it were. So by alternating between the two, the nose balances things up across the day so that it gives one smell system a rest and reverts to the other one periodically across the day.
Let's go to one on the voice note, please, line Johannes.
Hi, Lester. Please ask Chris, why do some birds hop when they're on the ground while others walk?
Go ahead, Chris.
I'm not an anatomist, but it'll be to do with what the leg bones are doing and the size of the bird. And some birds, very light, very small, much easier for them to flip about and just go hop, hop, hop. Other birds, much easier for them to waddle along. Of course, birds are most at home when they're in the air, which is what they're best adapted to do, to fly. So the ground is not really an ideal environment for them, unless they're a penguin, I suppose, where the ground is a compromise because they're on ice between where they would normally be, which is in the ocean, and wandering around on the ice, and they do waddle. But the answer is really going to come down to what's most energy efficient for that bird and most effective in terms of locomotion. So some birds, usually the bigger birds, will walk, transferring load from one leg to the other leg to the other leg, while smaller birds will find hopping is more energy efficient and anatomically more efficient as well.
A message on the WhatsApp line, and this is a conversation we had a couple of weeks ago. Chris, we're seeing and we've noticed in recent times TV chefs and YouTube chefs actively saying, you know what, add a little bit of MSG to your food. It will just make that taste pop out. But Johan asks from Zikofle, question for Dr. Chris, how bad is MSG for us?
Well, MSG is monosodium glutamate. So the first thing to say is, well, it's got a lot of sodium in it. That's effectively salt. And it will make food taste a bit better just because it's salty, because saltiness stimulates one of your 5 main tastes on your tongue, and it gives food an additional dimension. But it also puts your blood pressure up, and so that's not so good. Glutamate is an amino acid, glutamic acid, which is used in the brain as the brain's main excitatory neurotransmitter. So when a nerve cell wants to talk to another cell and activate it, it squirts a little bit of glutamate at that target nerve cell, and it revs up the activity of that nerve cell. Now, your brain is pretty good at keeping monosodium glutamate out of the brain thanks to a structure called the blood-brain barrier, but it's not completely perfect. And there are documented cases of people about 20, 30 years ago who developed a phenomenon that was being dubbed Chinese restaurant syndrome. And this largely stemmed from people called yuppies, who were these go-getter, hard-working, long hours, very driven businessmen in London, in the financial centres. And they developed Chinese restaurant syndrome because what was happening is they were going out for, fast lunches and long dinners in the evenings and eating enormous amounts of takeaway Chinese food from Chinatown, and it was delicious. And the reason it was delicious is they were putting in kilo quantities of monosodium glutamate into their cooking. It has the effect of enhancing flavour because your tongue can detect glutamate, and it gives the food a meaty, so-called umami flavour, which gives it another additional dimension alongside the saltiness and makes it taste very, very powerful. It gives you a big flavour explosion. But when you absorb all that glutamate, some parts of the blood-brain barrier, it turns out, are a little bit deficient and less good at keeping what's in the blood out of the brain. And that's there on purpose because your brain, and particularly a region of the brain called the hypothalamus, is always tasting the blood in order to work out things like how much sugar is in here, how much salt is in here, how much water is in the blood, so it can do things like coordinate what your kidneys are doing to keep your fluid balance correct, or keep your sugar level correct, or urge you to eat when you're hungry, and so on. And if you have too much glutamate being absorbed from your diet, it can actually cause excitotoxic. In other words, it can overactivate nerve cells in that part of the brain, and it can cause consequences. Doesn't happen too much these days because we've got a bit more sensible with how much MSG we put in our food. But if I was you, I would just focus on cooking with delicious, fresh ingredients and exciting, tasty recipes, and not cheat too much with the MSG.
And the are foods that contain natural, what would be considered MSG. Tomatoes, certain types of cheese has itself have levels of MSG in it.
Well, glutamate, as one of nature's 20 main amino acids coded for in our genetic code, is ubiquitous. It's everywhere. So anything you eat is going to have proteins in it, and it will have some glutamate in the proteins which you eat. So when you eat food, you will get glutamate out. It's one of those things that you will therefore absorb it, but you won't absorb it in massive quantities. And it's when you start putting it in massive artificial quantities that then you have a problem. A little goes a long way.
A question below the belt, but I think it's got to do with science. One person asks, why can one tolerate the smell of one's own fart but not someone else's?
I think it's a control thing, to be honest with you. And I think the reason for this is that you know who smelt it when you dealt it. But when you don't know where it came from, we're very highly tuned as a species, actually, to be very sensitive to hostile smells. And the reason is that hostile smells, and they aren't just farts, but they could also be decaying things, rot, ill health, they are all a danger signal to us. Ancestrally, if you came across something bad, we have innate within our biology a repulsion and we find repugnant, nasty stuff because it could infect us. So you steer clear of other people's waste and other people's dead bodies and other things' dead bodies because they could kill you, because they could infect you with things, they could actually make you unwell. So we have an innate intolerance of other people's smells and nastiness. We're more willing to put up with our own because we know that we're not going to infect ourselves with anything we haven't got already.
10 minutes left to get your questions into the Naked Scientist. Let's go to the voice note line now.
Hi, good morning. In the case of a top-loader washing machine, why must the outlet hose be higher than the machine itself?
Well, look, I'm not a washing machine expert or a washing machine engineer, but I would speculate that the reason for this is to do two things. Number one, so that the machine only loses its water when it wants to, because it'll have a pump which can develop a head and push the water up the hill a bit and then push the water down the drain. And then because there is that hill, you won't end up with it siphoning all the water out of the machine because the machine's higher than the drain. And you also won't have a problem with the water level siphoning back into the machine if something went wrong. So I think it's so that the machine doesn't actually empty itself by the siphon effect if the water's net got to go uphill a long way before it gets into the drain.
Thank you so much for that. Chris, I don't know if you've heard of the story coming out of South Africa this week of the South African woman reported to have had 10 babies, dectuplets. Officially, we've not seen. The South African government hasn't officially confirmed it. A major newspaper in South Africa has interviewed the family and interviewed the mother. But how is it biologically possible for a woman to carry multiple babies, looking at the nature and the physiology of the human body?
Obviously, multiple pregnancies do happen. The most common manifestation is twins. Twins affect about 1 in 75 pregnancies, and triplets affect about 1 in 75 squared pregnancies, and quads 1 in 75 cubed pregnancies, give or take rule of thumb. The way in which you make multiple babies can happen in two ways. One is that your ovaries, which are the structures either side of the uterus or womb which contain the future eggs, they can, rather than just releasing one egg at the right time of the month, can sometimes pop out more than one. And you therefore get 2 eggs coming out or 3 eggs coming out, and if there's sperm there, all of them can get fertilized. And then those fertilized so-called zygotes come floating down the oviduct and into the womb. And if the womb is in the right condition to be receptive for them to implant, one or more of them can implant. Now, if that happens, you get what's called non-identical twins. or quads or triplets. And the reason for that is that they're non-identical because each of them came from an individual independent egg, which is genetically unique, and an independently genetically identical sperm fertilized each one. So those are genetically different, each of those babies, as though you hadn't had them at the same time. They're no genetically more similar than if they've been born years apart. But you therefore can have multiple pregnancies that way. This can be a consequence of fertility treatment, because if we give drugs to women that make them increase their rate of ovulation, this can sometimes result in multiple pregnancies. People had a big rush of this a number of years ago when this technology was first being developed. We've got a lot more careful about how this sort of thing happens now. The other way you can get multiple pregnancies is if an embryo is formed, so a sperm meets an egg and that egg is fertilized and you get a zygote, a developing embryo. Sometimes, for reasons we just don't understand how this happens, but we know it does, the embryo at an early stage of development divides. And it divides into two, and possibly more sometimes, but certainly two. If it splits into two, if they are joined within a certain stage of development by an enclosing bag, then you end up with a pair of twins, genetically identical, but they're within one so-called chorion, the lining the membranes around them, and those are called monochorionic identical twins. Occasionally the two will separate and go their separate ways completely separately, and they're so-called dichorionic. They have two completely separate pregnancies, but because they came from one egg, they're genetically identical. So those are the ways in which it can happen. I've never heard of 10 babies being born in this way. I think that would sound like a very tall order for a woman to manage to rear that many. But certainly we've had 6 in the past. I'm certainly aware of sextuplets.
I see the BBC is also reporting on it. It's a bit of a mystery here in South Africa. Maybe some gatekeeping from a news company, but still a bit of a mystery.
Christmas is going to cost her a fortune, isn't it? I mean, let's be honest.
That's exactly what we're talking about. Colleen in Stellenbosch, good morning.
Good morning, Lester. Morning, Dr. Greg.
Morning.
My question is, why do some people overheat and other people are always cold? I have 2 friends, both overweight. The one is always freezing, and the other one is always dripping in perspiration.
Interesting.
There's a range of reasons why we feel the temperature that we do. We are homeothermic as a species. In other words, we strive to keep the same body temperature. And this is down to, we mentioned the hypothalamus earlier, a part of the brain that measures things about the body and then coordinates automatic responses subconsciously to keep the status quo. This includes how hungry you feel, how tired you feel, how thirsty you feel, how active you feel. And one of the jobs of the hypothalamus is to control the pituitary gland, which controls your thyroid, which is in your neck, and sets your metabolic rate. So one of the reasons why people feel sometimes too hot and sometimes too cold is because their thyroid gland is either too active or underactive. So that can be a reason. People who are very large, who have got a lot of body mass, have got a lot of insulation because fat tissue is incredibly good as an insulator. And also, when you are very heavy, you are doing a lot more work to move your body around than someone who's much lighter. Because if you think about it, if you weigh twice as much as another person, the person who weighs twice as much is doing a lot more work than the person who weighs half as much because they've got more tissue to move around. If you're doing more work, you're burning more energy. If you're burning more energy to do that work, you're producing more heat. And if you've got a well-insulated body because of extra fat, it's going to be harder for the heat to get out. So you could, for that reason, feel that you're much hotter than normal just through minimal exertion. And one reason why you might be very big but feel very cold, I mentioned the thyroid, is because if you have an underactive thyroid, the metabolic rate turns down and people do complain of feeling very tired, very lethargic, but also cold all the time. So if that's you feel cold all the time, thin hair, skin not quite right, very, very cold and tired, and weight gain despite not really feeling like doing very much, you could have an underactive thyroid, more common in women, might be worth getting it checked.
Thanks so much, Colin. John, you have the honor, the privilege of being our final caller this morning. How are you doing?
The question is, in somebody who's, for instance, right-handed and who, in preference, uses his right arms for playing tennis and his right leg for kicking a soccer ball, why isn't it when one looks at them naked that it isn't obvious that his right side of his body is much better developed than his left hand side of his body?
Yeah, there are various cartoons about men who play tennis and stuff like that who ought to be like a crab with a giant arm and a small arm. I remember seeing a cartoon like that about some of the Wimbledon tennis men at the finals. The answer is because there is an effect of developing the muscles that you use a bit more and making them stronger, but that effect isn't exclusively confined just to the muscle groups that you work out on. When you are working out, there's a stimulus that bulks up muscles everywhere, but does tend to produce a little bit more development of the muscles that's doing most of the work. So if you were, say, a tennis player or a golfer or something, the arm you are using to do that will have slightly more developed muscles and will be better at developing force more quickly. But because the stimulus goes to the whole body, all of your fitness and all of your muscles will also increase a bit. And partly that's not just because there's a stimulus going everywhere around the body, it's because in order to develop that force through your right arm and smash that tennis ball, if you think about it, you're doing a lot of other work elsewhere around your body. You're positioning your legs differently, you're changing your stance, you're moving your back, you're also balancing yourself with movements of the other limbs. And so for that reason, you're doing a lot of other movement and a lot of metabolic activity elsewhere in the body, although most of our attention is, of course, focused on the arm that's doing the smash. But a lot of that energy is coming from all around your body, so all the muscles are getting a very good workout and they all get bigger.
Chris, we'll catch you again next week, same time here on The Morning Review.
Thanks, Lester.
Have a
Great
good day.
questions this week, by the way. Brilliant.